Hello and welcome to part 3 of this series on how to build a WP-DAKSH tool changer. Today we're going to assemble the actual tool that works with the tool head, locking mechanism, and hosts the Hotend as well as the extruder. So before we get into the assembly, I just want to take a couple of minutes and explain how the toolhead is put together and the docking mechanism for the individual toolets. So in here we have the CAD design for the toolhead. As you can see, there are two parts to the toolhead: the Hotend mount, and it also includes the locking pins that go into the tool head and lock the tool in place using that nozzle clamp mechanism that we discussed in the last video. And then there is the extruder sitting up top here. Now, if you look at the extruder closely, it's a variant of the Sherpa Mini. Pretty much everything that is applicable to Sherpa Mini is applicable to this extruder as well. The only difference is the body shape that has been modified to sit on top of the tool head or the Hotend mount. So we have two variants of the Hotend mount. One is the one that actually uses the Dragon Hotend, and then the other one is which supports the E3D V6 or the V6 clones. Both of them are very similar except for the clamping mechanism for the two Hotends. The Dragon one has screws coming up from top that go into the Hotend. The E3D V6 one has that groove mount clamp in there. There is a 3010 Hotend cooling fan that is put on the side here that flows the air to the Hotend fins in order to keep it cool. In addition, there is an umbilical clamp or an umbilical mount that is used to clamp the umbilical and the PTFE with the filament down onto the Hotend. So it comes in this way, and then there is a clamp that allows you to just kind of pass the wires from here and go in into the CAN bus or the breakout board for the EBB36 that sits up here. These two holes are for the EBB36, either the CAN bus board or the breakout board. I'm using a breakout board, but you can use the CAN bus board as well. The dock essentially is comprised of two pieces. If I can just put them out here. So this is what the dock looks like. They are 4 mm smooth rods that go through the holes in the dock, and there are 5x11 magnets with 5 mm holes that sit in these two. Similar magnets actually go on into these holes here as well that clamp the tool onto the dock. And there are I think 10 by 3 mm magnets that sit in these holes to interface with the opposite polarity magnets that sit in here. So that is essentially what keeps the tool in place. The reason I'm using 4 magnets and the ones that with the holes in the either is because they're pretty strong and they actually have enough holding power to prevent the recoil of the wire loom coming in from top to push the tool back from its mounting position. And that essentially was a very important feature for me, that I should be able to have those stiff wire looms come in without them flopping around. The other part of the dock essentially is this mount that sits on the back 2020 extrusion. They have been designed to be about 56 mm in width, and they essentially can be installed next to each other. That essentially gives you the ideal position on where to put the tool to allow for enough clearance on both the sides. So this piece essentially just sits on the dock like this. So this is the whole assembly for the docking mechanism. There is also a purge mechanism and a purge bucket, but I will not go into this because I've kind of moved away from this after a lot of testing that I did with retractions and extrusions, and I've gotten to a point where I don't need a purge bucket during tool changes because there's hardly any ooze that is coming out with after all the tuning that I've done. I only have in the new version I only have a round brass wire brush that is rotated on its axis when the tool moves out and moves back in, and that is good enough to wipe any very minor residual ooze that might have come out, and I've been getting very clean prints without the need for a purge tower or a prime tower or any purging mechanism like a pebble wiper or anything like that. So I will be sharing the design for the new purging mechanism. So I will not go into this purging mechanism because this is an older version that I was working with. So the last piece of the whole tool assembly is this piece up here that essentially is used to have the wire recall come and clamp in on the top extrusion. So this is the extrusion that is sitting between the A and B motors, and this is the extrusion that is at the top of the frame. The idea with this whole wire management is to be able to enclose this printer from the back rather than actually having anything protruding out and not being able to enclose it. This printer is completely enclosable with an optional top hat that actually sits up there. Otherwise, it's definitely enclosable on the 3 sides without the need for anything to be protruding out. It's very keeping in line with the Voron ethos of just using the extrusions to be the way the panels can actually be put together. So that I believe is what the tool head or the tool assembly actually looks like. Just keep in mind that these pieces are these pieces on the tool, the one with the clamp pins protruding out, they are the ones that take the most beating in this tool changer concept. So I would definitely suggest for you to actually use something like normal ABS to print it. Eason ABS just doesn't cut it for me, and the strength is just not there. I've had so many of these pins actually break off when I was using Eason ABS that I actually switched to a local ABS manufacturer in India called Dream Polymers, and their ABS has been pretty strong in terms of the strength that it actually gives these parts. But I still have had a couple of instances where these tabs have broken off. even with the normal ABS, because there might be instances when you're actually doing a lot of tuning and the tool does not actually come in properly and it hits these tabs. Once the tool changer is operational, I don't think it's going to cause any issues, but you might actually break them off while you're actually tuning it off. So would definitely be good to actually print a few extras for both the variants, or depending on what toolhead you're using. I am actually planning to see if I can actually print these out of nylon carbon fiber filament to give it extra strength and rigidity. I have a couple of spools on the way that I will be printing these parts on, specifically just this part. Nothing else takes any kind of strength with this concept. The tabs are the ones that actually get clamped on and off. So would be good to actually have just this part be really strong, as much as we can actually get it. The other thing that I have discovered and would share as a tip while putting this together is always use super glue when you're actually putting in the magnets, no matter how tight they feel. I did not do that in the first instance, so I had I felt these holes were pretty tight with the tolerances and everything, and I just kind of pushed the magnets in there, and I've had a few of them actually come loose because of the repeated forces that actually act on them when you're actually docking or undocking them. So any magnet that goes into this concept should be held together or kind of bonded to the plastic part using super glue. Just use that and you will never have a print failure because of a magnet coming loose and the tool not being able to dock or undock. So that is just the other thing that I wanted to kind of put out there, that magnets should be held to the you should definitely put super glue when you're actually putting the magnets. And second, this part in here, just print it in the strongest ABS or strongest filament that you can actually print on, because this is the one that actually is going to take the most beating. So apart from that, everything else can actually print it in Eastern ABS or any other ABS that you have that suits your color scheme or anything like that. So that I believe is the overview of the tool. And now let's actually get down to assembling the tool and putting it together to show you guys how it's done. Just one more thing that I want to kind of before I forget, this micro switch in here essentially sits on top of this of the dock in here, and this is essentially to detect the tool being docked or undocked. So the tool changer software that I have written does a lot of intelligent error detection. So there is a micro switch on each of these tools, and there's a micro switch on the carrier as well. And it after every tool change, the system evaluates if the tool change was successful or not, and does error detection and pauses the print if it actually detects an error. And I cannot tell you, during the initial testing phase, or when I was working with setting up the tool changer, that has proved invaluable with the number of prints that it's actually saved for me. So that is one good thing that I've implemented. I'm really happy with the error detection. A lot of other things actually have gone into the software, but we'll discuss that when we actually get to the software part. So that is it for the tool assembly. Let's get down to assembling and putting a tool together. So let's move on to the physical assembly of the tool. As we discussed, the tool consists of 4 parts. We will start off by assembling the Hotend mount, then the extruder, the dock, and finally we'll put in the wire loom holder. So the Hotend mount consists of two parts that can go together like this. The Hotend fits in here. This one is specific to the Dragon Hotend, but there is another version that supports the V6 Hotend. There are 4 heat set inserts that are required. These are the standard Voron heat set inserts. So 1, 2, 3 and 4. These two are where the extruder mounts, and these two are used to keep the other part mated to this part. In addition, we also require a couple of magnets that will be pressed in here. So there are slots for the magnets. These are 8x3 N52 magnets, and there is another magnet that goes in to the part with the 2 tabs. This is an 11x5 magnet with a 5 mm hole in the middle, so it's like a ring magnet. And what we need to keep in mind is that the magnet should just sit beneath the surface on this part. So if you look closely, the magnet is not protruding out, it just sits a little bit beneath the surface. And when we actually move on to coupling the tool with the tool head, the reason for this will become apparent. So the part goes like the parts go together like this, and the tool head needs to be put in with the nozzle facing the back. I'm just doing this for demo purposes, so I'm not going to do all the 4 screws. I'm just going to do these 2 screws. So I already have the screws in there. I am going to tighten this one first, and then the second one screw, which is already in the hole. I'm going to tighten this as well, and the Hotend gets secured into the tool. So this tool, when assembled, looks like this. We need 4 M3 screws to couple these 2 parts together. 2 are M3x16s, which will go in to the heat set inserts. So all we need to do is we need to tighten them like this. So these are M316s. And then the other 2 are M3x20s that will go directly into the plastic. There are no heat set inserts here because there's no space to put heat set inserts here. But the plastic holes are thin enough to allow the M3 socket heads to make their own threads. So that is the 3rd screw, and this one is the 4th one. And we just need to keep in mind that the screws actually go into the head of the screws, sit beneath the surface of the tool, because this is where the tool gets mated to the tool changer carriage, and these 2 are the nozzles. These 2 are the nozzle holders. So these 2 are these 2 tabs are the V6 nozzles that we built in the last video. They come in here and clamp it down. So that is how you assemble the Hotend mount. So 1, 2 and 3 magnets, 4 heat set inserts, 2 here and 2 that are used to thread these M3x16s, and M3x20s that actually hold the whole thing together. So there is going to also be a PT tube that actually goes in here, but we will come to it when we actually couple this with the extruder. So now that the tool is assembled, let's move on to the extruder. The extruder itself again is 2 printed parts, or actually 4 printed parts. This is a modified body shell of a Sherpa Mini. So we have these 4 printed parts that will be used to assemble the extruder. These 2 holes are where there will be 2 magnets, again the ring magnets that we use on the Hotend. The same magnets will be used here, and this is where it interfaces with the dock. So let's assemble this. To assemble this, we essentially need 5 heat set inserts, and I have the heat set inserts right here. Let me just bring them out. So 2 heat set inserts will actually go in here, and I'm using 2 types of heat set inserts, if you can actually see closely. These are cheaper ones that do not have the twisted thread. The reason I'm using this in here is because I have loads of them, number one, and the second one is that these get pulled in from the back, so they are not likely to go out. So I try to use them wherever I can that does not affect the integrity of the parts, so just to save on some costs. So that is one heat set insert, and the other one goes in here. That is all that we need to do on this particular part. So these 2 heat set inserts here. On this one we need 3 heat set inserts, 1, 2, and then a third one here. So 1, 2, and then a third one in here. So we'll assemble, we put the first heat set insert in here first, then the second one. If you have assembled a Sherpa Mini before, it's exactly the same thing. This is just a modified body shell for a Sherpa Mini, nothing more than that. And then the third one where the idler screw is going to come in. So if you see, that is where the idler screw is going to come in, and these 2 are for holding the bearings down in here. So now let's go in and assemble the Sherpa Mini. So first thing, we need the gear. So I'm using a kit from Mellow, which has RNC coated gears and stuff. So you can just use a normal BMG kit as well. That is what I have on the other tools. So this bearing goes in here, and then it slides down into this. I'll just make sure that this actually rotates freely. We put this one, we combine both of them together, and then we use M3/16s to put to combine the 2 parts together. So let's see. Sometimes what I've also seen is that you can, I'm not sure if you can see, but there's plastic on these holes. So what I normally do is I take a bigger M3 screw and just thread it through so that the plastic actually gets dislodged. Otherwise it kind of creates problem in mating the 2 parts together. So if you see, this is the plastic that is coming out. I can just take that out, and now that hole is clear. I'll do the same thing on the other side. And do the same thing on the other side as well, so as to make a way for the M3 screw that we are going to thread in from the other side to actually go in smoothly. So now that is clear as well. So these two pieces of plastic have come out from the two holes. Now again, now we can just seat the gear that interfaces with the motor, and we use an M3x16 to thread it in. We can tighten this completely. We don't need to leave it loose or anything. So this is one M3x16. Then the other M3x16, have it here, which I'm going to use, and I think the original shape of the name BOM actually calls for button heads in here, but I only have socket heads, and I have not had any issues with using socket heads, so I think you can use either. Now the next part would be to assemble put the gear, the filament gear. So we take for the filament gears, we make sure that the flat side of the idler gear or the main rotating gear that interfaces with the motor, I don't recall what it's called, faces up, and then we align the grub screw with it. So if you see let's show you this. So if you see the grub screw, I'm not sure if you can see this. Yeah, the grub screw is aligned with the flat part. So we just take this out again and put it back in. So you see, that is the flat part of the gear, and I put the filament gear in. I press it down completely so that the filament path aligns with the gear. Let's see if I can focus in here. Anyways, if you look at anyone assembling a shaper mini, it's exactly the same process. Then I can just take the Allen key and tighten down the grub screw. That does it. So now the filament gear is rotating. There's another bearing that goes on the top. Let me see where the bearing is. It's right here. So it goes on top here, and then there are two M3x6 screws that go in here. I would suggest that you actually use the socket heads for these, because they are the ones that press down on the micro switch on the dock, and I'm not sure if a button would actually have that much travel to press down. So you can just tighten them fully in there, and that finishes the assembly on this part. Now this is the idler. So we have the other part of the filament gear that we can just take, and we press it down here, and it just goes in here. Then there is I think an M3 by 20 that again threads into the plastic in the back. That completes the extruder. The only thing that is left is the idler screw, which is what I have here, and there is a washer that actually goes in here on top of the spring, and that needs to thread in here. So that is what the assembly of the main part of the extruder looks like. Now we have two ring magnets. If you see here, these again are the same ring magnets as the one that we use on the Hotend. The polarity of these, what I would suggest is that you keep the same polarity on all the extruders and all the Hotends, and then the polarity on the dock would essentially be the opposite of this. So as to the dock and the carriage, both of them would essentially be opposite of what polarity you have here. So you start off by building one of these and then use the same polarity on all of the extruders that you build or all of the Hotends that you build, and that will correspond to the polarity of the magnets that you have on either the toolhead or the docks. So we need to press these magnets down in here. So again, I will use my trusty file to push this down. This is going to sit again very flush with the body. We need to make sure that the polarity of the two magnets are the same, so we essentially kind of just check the polarity and then push it down to ensure that they are the same, and we don't have an issue with that. So that finishes the assembly of the extruder. If you see, two magnets, the BMG kit that goes into the Sherpa Mini, and now these two are going to be mated together like this. The mating is going to go, the motor is going to be towards the tabs. So if you look at this, the motor is going to sit like this. The motor essentially is going to sit like this, and this goes on top of the carriage. On the docking side, we now have four magnets. If you see, 1, 2, 3, and 4. So that gives it enough strength to handle the recoil that actually comes with the wire loom. So to couple these two parts together, we're going to use M3 by 40s. So we need to open the idler and we need to push the M3 by 40s into these two holes here. I would suggest that you actually do this before you attach the motor, otherwise the motor screws are going to be in way of pushing this down. So once you have these down, so just need to make sure that it actually goes all the way down. So this is coming down here, and then we're going to do the same on the other side. I have the other so now this is where the PTFE tube comes in, so I would have to loosen these two screws a bit to allow the PTFE tube. This is the PTFE tube that goes between the extruder and the Hotend. This gets pressed down in here, and the extruder gets put on top of the Hotend. Again, what we need to keep in mind is these two magnets should be in line with these two magnets. This is where the dock actually interfaces. On the front, it's just a single magnet. The front essentially is the part that goes into the carriage on the X gantry. So we interface them together. So I just need to kind of back this up a bit, back this one up a bit as well, align two parts, and then just have them go into the heat set inserts. So we just tighten this down. You want this to be tightened down completely because this is what is going to determine how the alignment with the carriage actually goes. So this, when you assemble this should be the final assembly that you should do in terms of tightening everything down, because this is where the carriage is going to interface. So we need to make sure that we have the correct height on these two holes to interface with these two holes, so interface with the carriage. So if you look at this now, this is what the front of the tool looks like, and this is what the back of the tool looks like, which interfaces with the dock. The final thing that we need to assemble on this is the wire loom to complete the tool. So the wire loom holder is this part here. This needs 6 heatset inserts, 2 that go in here for the motor to thread in, 2 that go in here for the piggyback board that I have to actually sit. This is the board that I use to interface with the Hotend, the thermistor, and the extruder motor and the Hotend fan in here. And then another 2 that need to go in here, which is where the wire loom will be mounted. So to finish the assembly of the extruder, we put the motor in here like this. We put everything together, and first of all, what we can easily do is first we assemble the extruder. We can actually kind of just, we have a button, M3x16 or M3x20, I think this is button that needs to go in. So sorry, this is the one that needs to go in. This, I think this is M3x20 or 25. I will post this in the BOM. It needs to thread to this part, and then there's another one that I think this is M3x25. The second Allen bolt, which is the M3, the socket head, needs to go in here. And now what we can do is we can just kind of interface this with the mount. So
there is a bit of work that is involved to make sure everything is aligned correctly, but it pretty much is, everything falls into place once you have the alignment on one side done. So if you look at this is essentially is going in and into the hole on that side, and then it just kind of threads in. And same thing happens on the other side as well. I'm sorry if the camera angles are not good, but this is, I hope you get the idea into how the assembly is being done. If there are any questions, that let me know in comments and I will clarify on that. Okay, so now that we have the loom assembled, we can put the idler screw back in. So that essentially is what the tool looks like when it is fully assembled. So this is the Hotend holder or the Hotend mount. This is the extruder, which is a variant of Servo Mini, and this is the wire loom holder that actually plugs in. The final step for me would essentially be to use this piggyback board and just mount it in here, interfacing with the using M3/6 or M3/8s to mount the piggyback board onto it, which is where everything else can be connected, and then the connections can happen using a microfit connector that is here. So let's do this, and then the final one that we need to do is this one here. And so this is done. The motor will slot in here. That completes the assembly of a single tool. Remember, you have to do 6 of these with either the V6 or the Dragon Hotend. Now there is a PTFE coupler that actually needs to go on top of the extruder, which is an ECAS 041. So we will just put this in and press it down using a trusty file, and that is it, I think. That is an assembled tool head. Lastly, we forgotten the fan in here, which essentially needs to go in this slot. So it's a 30/10 fan that sits here. So this is the Hotend fan. The air blows into the Hotend here and comes out of this area and the front. So My initial apprehension was that this is not going to have enough air clearance, but during my testing I've not found any issues with the way the hot and front fan has been set up. So I think there's no issue in here that needs to be addressed. So that is the fan, and then we have the heater that needs to be put onto the other side. So the fan is going to be on one side, the heater wires are going to be the other side, and there is, if you look closely, there is space that has been built into the sides of the two parts to allow the heater wires and thermistor wires to actually pass through. So they will come in here, and then they will go, they will ride, so they will start off from here, they'll go in, come out from here, they will be carried over from beneath the motor holder, or the volume holder, and they will go into the interface board in here. So there is wire management that is being done in here, and I can just show you a finished tool in here. So let me just show you this tool. So you see there's the Hotend and the thermistor wires. They go in and they come out on the side in here. They go from between the space between the motor and the volume holder, and then they ride up and are connected into the into the piggyback port right here. And so that is how the wire management needs to be done on this tool. And if you see the way the volume holder works is that there is another part that actually needs to fit into the wire loom. This is the microfit connector that is carrying the wires to the board, and this is the spring steel wire that keeps the shape of the loop to be a consistent arc. This is one of the most important things that I've done in order to get good wire looms that do not slop on this side or kind of just look awfully bad. So the thing to remember is the thermistor and the heater wires ride up from one side, and the fan wire rides up from the other side and from underneath, and then they go into the piggyback board, which then uses a microfit connector, 8-pin or I think 16-pin microfit connector, to carry the wires back into the board. So that is how the wire management needs to be done on the tool. So the dock consists of two parts, or three parts actually. This is the main body of the dock, which is going to get connected to the this piece which sits on the extrusion. The tabs on the piece to fit into the 2020 extrusion. It's going to sit like this, and then there are going to be two screws with T-nuts that actually go in here, and another screw with the heatset insert in here, which I'll just put in. The idea behind this is that I should be able to raise the dock up or down. Ideally, this should not be required if your printer is square, and if your gantry is square to the back extrusion, but I've seen sometimes that in builds that is not often always the case. So this allows for a limited amount of movement, a couple of millimeters up or down, to allow for the dock to actually be in line with the gantry and the carriage that is coming in to pick up the tool. The third part of the dock is the purge and the nozzle parking mechanism, which is this part here. So this is already assembled. There are it's a very easy assembly. So this is one part that, if you look closely, has a silicone strip in here, a small silicone strip. So I am using something like this that I bought off Amazon, and I'm cutting strips out of this to put in here. This is like an ice cube tray that I bought off Amazon. So there's one strip that goes in here. This is what the nozzle gets parked on, so the nozzle is not leaking filament. So this kind of just blocks that nozzle orifice and stops the filament from coming out. Then there is a tack, a brass tack, similar to the pebble wiper, that actually sits in here, which when the tool is pushed out, which extrudes filament in here to form a pebble or a blob of filament, waits there for about 4 or 5 seconds, and then it pushes out. So when it pushes out, it kind of goes and hits these silicone strips, which again come out from that same piece of ice cube tray that I have. So it kind of just takes that blob that was created and detaches it from the nozzle, and then the final piece in here is this container that sits in here as part of the nozzle cleaning system. So any pebble that actually gets detached from the nozzle does not go in here. It just kind of does not go out or into the bottom of the printer. It kind of just sits and falls into this container here, which can be removed and emptied when it gets filled up. So this is the purge solution that I've come up with, and I found it fairly effective in eliminating the need for a purge block or for stopping zits or pieces of oozing filament to actually go onto the prints. So we'll keep this on the side for now, and let's assemble the dock. What is important in the dock essentially are the magnets, but for first we'll start off with the heatset inserts. So we need 4 heatset inserts, 1 and 2. This is to actually attach the container to the dock here. So let's just put the heatset inserts in. Again, I'm using the cheaper heatset inserts rather than the more expensive Voron ones, because as I said, I have a lot of them that I need to somehow use. On the back, these 2 holes are where the heatset inserts are going to go. The other 2 are going to be used for aligning the tool with the carriage to make sure that the height of the tool and the carriage is the same, and we'll go over that once we actually get to the part 4 or 5 of the video, where the carriage actually gets aligned with the individual tools. So now that these are in place, what we um, need to do is to actually um, install the magnets that need to be installed. So now this is where the polarity comes into play. So we need the tool head that is going to be mated to this particular dock. Ideally, I would want the polarities of everything on the extruder to be the same and everything on the dock to be same, so I can actually interchange the tool heads. But if for some reason you do not get to do that, the idea would be that you at least mate the tool head with the dock which is specific to that particular tool head. So this is I've put in 2 more ring magnets in here, and they will go into these 2 holes. So what I will do is I will just press down on this. So one of these has actually gone in very nicely. I will just press it in using my trusty file again, and then the second one needs to go in. So now that we have this polarity handled, we can just use this as the reference and push this in. So these are tight fit for a reason, because there's a lot of force that is exerted on them. We don't want the magnets to get loose. So I would definitely also suggest you use some kind of a super glue or something in here if you can, and so that does it. Now what we need to make sure is that this gets clamped properly on both these sides. So now that that is in place, we need to look at the bottom 2 magnets as well. So we have 2 other magnets that we need to put in. So again, this we need to make sure that this actually goes in like in the correct orientation. So we'll just take this and push it out. Sorry. So this needs to go in here, I think, and then we can just push this down. Actually, I might just need to put some super glue in here, because if you see, this has come out. So to secure this, I think I'll put some super glue in here on this. So I have this small orifice in here that I can use to put some super glue on these 2 magnets. And we just use the polarity of these to put these. See, so if you see this magnet in here, we need to install it onto the stock. So what we do is we take this and we install it like this. Use a trusty file to just push it down into the hole. So just put a dab of super glue in here, use this, and we then push this down. Same thing we'll do with the other side as well. Okay, so now I'm just missing 1 magnet in here, 4th magnet. So We have this. Now we can actually put this magnet in here. That's it. We have our trusty file doing the work. We just press these down to make sure that they are not protruding out, and we have ourselves the dock. See, the final part in the dock is to attach the black piece, which is going to sit on top of the extrusion, to the dock. So this there will be M3 by 12 screws that actually go in here, and they will fit into the heat set inserts that we actually put in. I would not want to keep them completely tight right now because there's one additional step that needs to be done. So we have these, we have the dock, but what we also need is two M4 rods, smooth rods that have been cut and which can slide between these ring magnets. What this does is that this allows the tool to first of all be aligned completely with the dock, and secondly it handles a lot of the recoil that happens because of the wire loom and the spring steel wire. So if it kind of goes, if I was to just kind of put in the dock without it and the recoil happens, the tool will go like this because there's a lot of recoil that actually is happening. With these, that recoil is managed much better. So what I would do is these need to be put in with some of the super glue. So I will take some super glue and put it into these holes. Take these linear rods and just kind of push them till they come close to the back. See, I used too much super glue in there, but there is enough space in here to allow super glue to actually go in. What this does is it actually locks it into place. We don't need a lot of the rod to actually stick out. All we need is just enough to handle the recoil and align the tool with the dock.